All right, let's go ahead and talk about factoring whole numbers from section 1.6, objective 1. We're going to use some factor trees. You may or may not have seen factor trees before, but they're extremely useful when we get to operations with fractions and writing fractions in lowest terms and things like that. So before we talk about division, we're going to talk about factoring. So our first example here asks us to write the prime factorization for the composite number 24. A composite number is a number that has more than one prime factor, and a prime number can only be written as one and itself for factors. The first prime number being 2. So let's look at this here, and it's an even number, so we're going to start with 2. It's 2 times 12, and then 12 is still an even number, so that's 2 times 6, and 6 is an even number, so that's 2 times 3, and here's my prime numbers, 2s and 3s. I have 3 2s, so 2 to the third power times 3 is our prime factorization. So 2 to the third power times 3. I'm using a multiplication dot. I believe that that's how it would be represented in MyMathLab here. So now let's look at the composite number 88. 88 is 2 times 44, which is 2 times 22, which is 2 times 11, and 11 is a prime number. It can't be broken down anymore. So 2, 2, 2, and 11 is 2 to the third times 11. It's important to be able to recognize prime factors. So let's talk about prime numbers from 1 to 100. I'll just go ahead and give you a way to find them here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to make a chart here. 91, 12, 22, 32. I'm just trying to make sure I give myself space, writing my rows first here. Space everything out well. And just give me a second to write everything from 1 to 100 for you. Seems like it's going to be a lot of work, but it's not. I'm going to teach you a principle about any grid like this, that if I want to find all of the prime numbers between 1 and n squared, so 10 squared is going to be 100, I set up a grid that's n by n like this. And once I get done with the first row here, then everything else that's left after I'm done with that first row is going to be a prime number if it's set up square like that. So this won't take long at all. The longest part here is the setup, 20, 30, 40, 50, 60, 70, 80, 90, and 100. All right, I already told you by definition, 2 is the first prime number. So we're going to cross out every other number because that will be a multiple of 2. So 4, 6, 8, 10, 12, and so on. So that's going to be everything in this column that ends in a 2, everything in this column that ends in a 4, everything in this column that ends in a 6, everything in this column that ends in an 8, and everything in this column that ends in a 0. Those are all composite numbers because they are 2 times something. So then the next number is 3. We're going to cross out all the multiples of 3, moving 3 at a time. Every other one will already be crossed out if it was even. So 6, and then 6 plus 3 is 9, and then plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21, plus 3 is 24, plus 3 is 27, plus 3 is 30, plus 3 is 33, plus 3 is 36, plus 3 is 39, plus 3 is 42, plus 3 is 45, plus 3 is 48, plus 3 is 51, plus 3 is 54, plus 3 is 57, plus 3 is 60, plus 3 is 63, plus 3 is 66, plus 3 is 69, plus 3 is 72, plus 3 is 75, plus 3 is 78, plus 3 is 81, plus 3 is 84, plus 3 is 87, plus 3 is 90, plus 3 is 93, plus 3 is 96, plus 3 is 99. All right, now the next one is 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. You saw that cleared out everything in this column that ends in a 5, and everything in that column that ends in a 0 was already cleared out. But we know that, so let's go back for divisibility by 3, is if the sum is of the digits adds to a number divisible by 3, it's divisible by 3. If it ends in 5 or 0, there's no nice test for 7, but once we get done with 7, we're done with this row and we're done. We're just going to have to move by 7s, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, 98, and we're done. So everything that's left, because we reached the end of this row, everything that's left is a prime number here that could potentially be something that we would use in our factor trees. So I think I got them all here. That's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 89, 83, 89, 97. Now those are just the prime numbers between 1 and 100. There's lots more prime numbers. We don't really know right now in math if there's such a thing as a largest prime number. We say that we don't think that there is, but we're really not sure about that. But we're probably going to be dealing mostly with prime numbers that are in this list for this class. You won't be dealing with gigantic numbers that may end up to be prime that you wouldn't be able to use any of the tests that I've given you for divisibility to figure out if it's prime or not. So, okay, that's it for this video. I know this one was a little bit longer, but prime numbers is something that is a topic that we need to refresh and go over before we talk about division and fractions. So let's leave that there. We'll come back next time and talk about division of whole numbers and what this prime factorization has to do, that if a number is divisible by something because it has a factor of that, then it's going to have a whole number answer for the quotient. But we'll look at that in our next video. So see you for the next video.